Welcome to our 10th week of digital distance learning. Oh my god, it's been already 10 weeks. I can't believe it. Anyway, we are going to be focusing this week on solving inequalities the same way we used to solve equations a long time ago, and we're going to continue with our number lines as well. One more thing to remember, please make sure you have your pencil and your notebook so you can take a picture at the end of your notes and send it to me. And at the end of this video, make sure you watch. We are going to recognize a very special birthday that I think you'll be happy to hear about. Bye! N is there. We are going to subtract 1 to cancel out plus 1. The opposite is minus 1. And on the left side, I am left with an N is greater than 3 minus 1, which is 2. Now, the way we write this, or we say this, is greater than. N is greater than 2. We can also say N is more than 2. And to make the number line, we have 0 in the center with positive numbers to the right and negative numbers to the left. We are going to put a circle at the number 2 and leave it open since it is greater than. And our arrow is going right to follow the sign. Now let's begin solving on the right since my variable n is on the right. I am going to add 2 on both sides to cancel out my negative 2, and I am left with 1 plus 2, which is 3, is greater than my variable m. Because I like my variables at the beginning of the inequality, I am going to flip this inequality so that n is less than 3. These are equivalent inequalities, so nothing has changed other than the order. We read this as less than. M is less than 3. Now we are going to draw a number line. We do not have to have 0 in the center, but it is helpful if possible. Since we are dealing with small numbers, that's an easy thing to do. Let's put a circle on the 3, and we are going to have an open circle with an arrow to the left. In this example, we are going to begin solving on the left. We are going to divide by 3 on both sides because the opposite of 3 multiplied by k, 3 times k, is division. When I divide, I am left with k is greater than or equal to 6 divided by 3, which is 2. We are going to read this as greater than or equal or more than or equal. Remember, both ways of writing it are correct. K is greater than or equal to 2. Now on to the number line. We are going to draw a circle, a positive 2, and notice I am going to color in my circle, and that is because we have that equal sign. It's greater than or equal, which means we are including the number 2 in our answer. K can be number 2, but it can be the number 3, the number 4, the number 100. Anything that is exactly 2 or greater. In example number 4, we are going to begin solving on the right because my variable h is on the right, and I am going to multiply by 2 on both sides to cancel out divided by 2. We have 2 times 1, which is 2, is greater than or equal to h. Of course, I want to flip this around so that my h is at the beginning of the inequality. And notice that I have to flip everything around, the variable, the number, and the sign. This reads as h is less than or equal to 2. On my number line, that is going to begin with the number 2, and we are going to have a closed circle because we remember that that word equal means that it can also be equal to the number 2. H could be 2, or h could be anything less. It could be 1, it could be 0, it could be negative 100. Anything equal or less than 2. Solving equations and solving inequalities is almost exactly the same with one small exception. Let's take a look and see if we can figure out what this exception is and why. Here we have 3 equals 3. I don't think anyone will argue that that is true. Let's add 1 on both sides. When we do that, we have 3 plus 1, which is 4, is equal to 3 plus 1, which is 4. And that's correct. Well, let's see if I can try it again with different numbers and with a different operation, and it will still work. We have 5 equals 5, and I am going to divide it by negative 1 on both sides. When I say 5 divided by negative 1, I get negative 5 on the left and on the right. We are doing the exact same operation to the exact same numbers. But let's see what happens with inequalities. Well, 1 is greater than 0. We all agree with that. And if I add 1 on both sides of my inequality, 1 plus 1 is 2, and 0 plus 1 is 1. 2 is greater than 1. This is still true. This is still the case, and it would be the case if we had less than or greater than and equal to or less than or equal to. But let's see what happens when we divide by negative 1. Well, 1 divided by negative 1 is negative 1. And 0 divided by negative 1 is 0. But hold on, negative 1 is greater than 0. That's just not true. What happened? We have to make this work, but it's just not true. Negative 1 is on the left on the number side, and on the left we have negative numbers. We have smaller numbers. So when I look here and I say negative 1 is greater than 0, I know that that's not going to work. How can we make this work? Well, we have to say that 1, 2, or 3 are greater. Negative 1 is in fact less than 0. So when we multiply or divide by a negative number, to make this true on the number line, you have to say, I am going to flip the sign. So let's see how that works. Here, I am going to multiply by negative 2 on both sides. When I do that, it cancels out on the right, and I am left with negative 2 times 1 is negative 2. Less than or equal to, I have to flip the sign, h.